Alright, hey guys, what's up everybody, and welcome back to part 2 of the Apex Academy of Mathematics video tutorial. And this is part 2 of addition and subtraction of directed numbers, or numbers that we otherwise call integers. Alright, so if you did not watch part 1, I have basically rewritten for you here the rules that we actually physically went through by writing down the definitions. So right here I've written them down for you, which I'm going to kind of reiterate for you here. But you should definitely check out part 1 of that video. It's somewhat of a lengthy video, but we went through some very fundamental but important principle towards addition and subtraction of integers. Yes. All right, good. So in part 2 we're just going to reiterate the rules, or what we call the textbook or standard rules for addition and subtraction of integers. And then you can see here on page 2 I've created some questions here which we're going to be running through and using this standard rule to work these questions out. Plus I have left a notation here for you down here, which we're going to be explaining what this concept means in a moment. All right, good. So let's pick this video up from the last one. So we explained in part 1 that if two integers have the same signs, we add both numbers and we keep the sign that is common to both numbers. And I have an example here. Here we have -4 and we have -3. All right, so what we're going to be doing here is that since both integers 4 and 3 have the same signs here, we're going to add both the 4 and the 3 together, so that gives us 7. But since the negatives are common to both numbers, then we pretty much leave our answer as -7. All right, and same here with this very, very simple math, which most persons know that 10 plus 3 is in fact 13. Yes, but the reason behind this is since the 3 here is positive and the 10 here is positive, there's an understood positive sign here. The both signs are the same, so we just add both numbers and keep the sign that is common to both numbers. So that basically concludes the first standard or textbook rule for addition and subtraction of integers. Now the second rule is for when integers have opposite signs. All right, so it says here that if two integers have opposite signs, then we take away the smaller integer from the larger integer and we keep the sign of the larger integer. All right, and here's an example here for you, like what we went through the last time. Here we have a very large integer, which is 8. All right, so it has a plus sign in front of it here, and we have the number 3 here, which has a negative sign. So two integers, so we take the smaller one, which is 3, and we take that away from 8. So if you take 3 away from 8, you should get 5. But since the larger integer has a plus sign and they are opposite signs, the rule says that we keep the sign of the larger integer. So the larger integer is 8, so we are going to keep the plus sign. Now we did not write a plus here because we know from the previous video that whether we write a plus or we do not write a sign, this number is understood as a positive value. All right, and example number 3 here, where the 13 is the larger of both integers, all right, and 9 is the smaller, so we take the 9 away from the 13 and naturally we would get 4, but the result is negative because the 13 has the sign, the larger integer has a minus sign, so your end result will be minus. All right, so these two rules here, all right, we're going to be applying them in some of 3 examples that I have on page 2. Right, we're going to be working these questions out, and we're going to be using these very same principle here to work this out. All right, guys, so let's go to that page now. All right, so here we go. So let's look at question number 1. Right, so what we want to do here, okay, so we have a black. Let me just use a different color ink here. All right, good. Okay, cut it out. Let's use blue. All right, good. So the best way, and remember, we're not using any calculators here, we're trying to use the rule to our advantage here. All right, that's the essence, that's the importance of this video, is to avoid using the calculator. Okay, so what we want to do here is that we want to put these numbers into groups of 2. All right, so we've got, we can use brackets or parentheses if you like. We can use that, or we can use lines. Now you've got to be very careful, because what I see a lot of students do is that sometimes when they use the brackets, for example here, let's say you do this and you do this, and then you do this and you do this, and then you do this and then you do this. Okay, so when you do it like that, okay, when you do it like that, you're going to make fundamental errors. For example, this part here is fine, that's good. This part here is okay, and why you're okay is because whether you bracket, or whether you put a bracket in front of the plus or behind the plus, this number will still be understood as a positive. But where the error comes in here, and this is a fundamental error here, is right at this point right here, where you put a bracket in front of the 11. So what that does is that changes the actual outcome of this calculation here, because before this was there, this number was actually a negative 11, but because you put a bracket here, all right, let's just move this up a little bit. Okay, so because you put a bracket here, you turn this negative 11 into a positive 11. So using parentheses or brackets, you've got to just be very, very careful with how you do that. What I do suggest though is that you use lines. Okay, so you do stuff like, do a thing like, okay, you put a line here for these 2 numbers, then you put a line here for these 2 numbers here, then you put a line for these 2 numbers here, and you've got to be aware. You got to be aware of the signs that come in front of the number. Okay, all right, you just got to be aware of that. All right, good. So let's take care of this math. All right, so with that explained, let's move on, work this out. So here I'm gonna work out these first 2 numbers right here. Okay, and the 2 numbers here have the same signs. So according to the rule on page 1, is that if 2 integers have the same signs, then we're going to add both numbers, and we should get 11. And because the sign is common to both terms, it will be negative 11. So this part here will give you 11, but it's going to be negative. Yes, let's write it a little bit better here. Okay, all right, so this is going to be negative 11. Okay, all right, good. Now do not rush to put down a sign, because we don't know what the outcome of this end result is going to be, whether it's going to be positive or negative. So take in consideration that this negative has a plus sign, so this is positive 11 here. So if we take 6 away from 11, we should get 5. But is it positive 5 or negative 5? Let's find out. So the 2 signs are opposite. So the rule states that we take the smaller number from the larger number, and we keep the sign that is of the larger integer, and that's positive. So this should be a positive 5 right here. All right, and then for these two numbers, now this is where the trick comes in. You got to be careful because this number here is minus 11. Okay, minus 11. So you can see that this integer here and this integer have opposite signs, and if they have opposite signs, the rule states that we take the smaller number away from the larger number. So 4 should give us 7. Yes, it should give us 7. But this 7, is it positive or negative? Well, the larger integer has a negative in front of it, so this is going to be negative 7. All right, so now we've reduced our arithmetic math here, or arithmetic math, but we have reduced our arithmetic here to from 6 digit numbers to 3. So we can't put these all together at once. So the easiest way is to put it into groups of 2 here. So we're going to put here, we're going to have an odd number waiting. So this minus 7, we could bring it down right here and wait for the result of these two right here. Okay, so these two have opposite signs here, right here. So we're going to take the 5 away from the 11 and we should get a result of 6. But is it? Okay, so okay, just a second. Okay, so is it negative or positive 6? Well, we know the result is 6, but since the larger of the two integer takes a negative, then it will be a negative 6 right here for this part of the calculation. Okay, and then now finally we reduce this answer here to having the same signs right here, same signs. So we're just going to be adding the 6 to the 7, and that should naturally give us a result of 13. But since they have the same signs, let's just write this a little bit clearer for you. Since they have the same signs here, then we're going to keep the sign that is common to both numbers, which in this case is negative 13. So this is our answer. Now that took quite a while in terms of the calculation, but the more you understand using this concept is the faster you'll be able to do it. All right, so let's jump to example number 2. All right, good. So example number 2 here. So let's quickly run through these remaining problems here. So we're going to put this here, this line here, and then we're going to put 2 lines here for these two, and then be careful now right here, be careful right here. Okay, so put 2 lines for these 2 here, and we're going to leave that odd guy right here. So this 20 basically will come down waiting for these results here. All right, so let's look here. So these two basically have opposite signs, a positive 13 and a negative 17. So that's opposite signs, so we take the 13 away from the 17, and that should give us a result of 4. Okay, that should give us a result of 4. But since the 17 is the bigger integer and it's negative, so that's negative 4 here. All right, good. So let's go to this next one here. They have the same signs here. So we're gonna add, in this case, so we're gonna add 6 to 9, and that should give us 15. But is it positive or negative? It's going to be negative because the common sign between these two integers is negative. So we end up with a negative 15 here, and we have a negative 4 here. All right, and these two here, they also have the same signs here, same signs. So we're going to add again, and that's going to give us 20. Is it positive or negative 20? Well, it's negative 20 because this here have the same signs, and this was initially here a positive 20 right here. All right, good. All right, fantastic. All right, so we have 4 integers, so we can put these into groups of 2. All right, so we're going to put a line here and a line here. All right, so now what we have here is negative 4. So these two same signs. So we're going to add both numbers, and that should give us 19. But is it negative or positive? It's going to be negative because both integers have the same signs. So we add and we keep the sign that is common amongst them. All right, and then this part here, well, this is interesting. Let's draw an arrow pointing to this identity here. Let's use orange here. So this, we can explain that part in a bit. All right, so momentarily I'll get to that for you. So this part here works out to be 0, 0, 0 here. So that is going to be, we know that 0 is neither positive or negative, but and 20, they're both like, so if you put a minus 0, it doesn't matter, or if you put a plus 0, it does not matter, because neither number is greater than the other. All right, so it doesn't matter in this case what you're gonna get. So I'm gonna put a plus 0 since that's acceptable. All right, so this works out nicely now to be same thing here. You're gonna add nothing to a number, you're gonna get back the same number. All right, this specifically is called the additive, or the additive identity, which in future tutorials you're going to know what that means. All right, so that takes care of this question. All right, that takes care of that question. All right, so let's just run through this one real quick and then get to this definition here, and then we can wrap this video up in a moment. Okay, all right, so quickly, so let's put two lines here and 2 lines here and 2 lines here. Okay, and these two opposite signs. So if it's opposite signs, we're going to take the 9 from the 17, and that should give us 8. Is it negative or positive? All right, good. So I know you know that that's negative 8 because the 17 is the larger integer and it has a minus sign, so that goes there. So for this one here, okay, they have opposite signs. So just like this one, we're going to take the 6 from the 11, and that should give us 5. But is it positive or negative? I know you know this answer. That it's going to be a positive 5 right here. All right, and these two here, okay, so opposite signs again. So we take the 3 from the 6, and we should get a positive 3 because the 6 is the larger of the 2 integer. Okay, all right, so just like problem number 1, we end up with an odd set of numbers remaining. So we're gonna have to work out these two and bring this guy down here, waiting for the answer for those two there. Okay, all right, good. So opposite signs. So we add we take the 5 from the 8, and that leaves us with a negative 3 here, negative 3. Let's just write that a little bit clearer for you here. All right, good. So that's negative 3, and see here again, wow, that brings us to this identity here, which is now going to be an end result of 0 for this answer. Okay, all right, good. So we were able to quickly run through this these 3 questions. Took quite a while, but I wanted you to understand the concept behind this. So let's wrap this video up in a few minutes now, and we're looking at what is called the additive inverse identity. This tends to give students a bit of trouble sometimes, where they tend to, overthink the question. For example, a student may think that this here 6 plus 6 is negative 12. That's a very common mistake. Or this thing here, most persons will get this one right because it's kind of straightforward, but this one, it tends to trick quite a few students, especially if their fundamental math is weak. So this 6 plus 6 thing here, you gotta be careful that this is not 6, it's actually negative 6. All right, good. So with the additive inverse identity, which NB means nota bien, note well, this identity states that if, actually this is supposed to be an integer, okay, that's supposed to be an, so if an integer is added or subtracted from or to its opposite value, then the end result is 0. So here we have negative 6, and we're adding it to its opposite value, which is positive 6. Whenever that happens, the result will always be 0. And here we've turned it around, where we have a positive number in front and a negative number at the end, positive with a negative same number, that gives us an end result of 0. So look out for this during your calculations, guys. Okay, all right, fantastic. All right, guys, so that takes us to the end of this video. This kind of help us to understand a little bit more about how we utilize these standard rules for addition and subtraction of integers. All right, guys, so good. So if you have gotten some value from this video, please make sure that you smash that subscribe button here. Okay, that subscribe button right here. Okay, this pops up right in front. Okay, so you gotta smash that subscribe button, hit like if you like this video, and make sure that you help me to help others out there who are struggling with this aspect of the math. All right, guys, thank you so much for watching this video, and below for any information. Again, you can check me out on Facebook, Instagram, Twitter, and you can DM me my personal WhatsApp. Right, guys, so be sure to keep practicing, and you're going to become and unlock that genius that lies within you. Okay, guys, so take good care, and I will see you in my next tutorial video, part 3, where we're going to be talking a little bit about the O and have technique aspect of working these questions out. All right, so take care, and I'll see you soon. Bye bye.